Hello, my name is Brock Langren, and today I want to talk about my Math 321 final project, sliding piece of metal. As an overview, I want to find the distance a piece of metal travels over time down a ramp. My plan is to drop the piece of metal from the top and watch as it falls down. The assumptions made for the recording process is the ramp is a thick, flat piece of wood. The ramp's angle is set to 45 degrees. The mass of the piece of metal was not recorded due to not using it in the formula. The piece of metal sliding down the ramp will be recorded in slow motion, so I can pause the video and measure the time and distance. The assumptions made for the differential equation, though, were gravity, velocity, distance, and time will not be accounted for. Sliding friction, mass, and air resistance will not be accounted for. And we know that the mass times dv over dt is equal to gravity times sine of theta. We also know that ds over dt is equal to velocity due to time. The tools used were a long, flat piece of wood, tape measure, a piece of raw steel metal, angle finder for 45 degrees, and video recording in slow motion. As you can see, on the left we have the piece of wood and the angle finder at 45 degrees, and on the right we have the piece of metal. The piece of metal is dropped from the top of the piece of wood and slides down and is recorded with a tape measure that runs the entire length of the wood. Some of the calculations necessary for the IVP start with finding VT. As you can see here, we have a first order linear inseparable equation found from that equation. So basically I just went ahead and separated it and came up with the equation here for velocity, and that's gravity and time. Those are the variables, and that's going to be used down here on the distance formula, where ds over dt is equal to vt. Again, we have a first order linear inseparable equation. I went ahead and separated this one as well, and down at the bottom here is what we came up with for our final answer. So moving on, we have the data. You can see on the left we have the recordings, and on the right we have the formula. So the data on the left is what I recorded from the video, and the data on the right is from the formula plug and chug. Below, moving on, we have graphs. These graphs are, the one on the left is the recording, and the one on the right is for the formula. They have similar trend lines, but as you can see, the results here, the data is quite different. The graphs have similar trend lines, but there's different data points in general. I mean, they're not even in the same realm. We're talking feet compared to inches here. And my conclusion is that my IVP doesn't represent the data very well. With that being said, it doesn't represent the data very well because I just didn't have enough stuff to include in the equation to balance it out. What I would do different is include sliding friction, mass, normal force, and air resistance to represent the recorded data more accurately. And I would also try and measure the distance and time to get velocity, as that is more intriguing than just distance. With that being said, thank you for listening, and here is the original sliding motion video.